So I have a very simple project set up to explore Selenium. Let's look at our pom.xml file first to see what we need to get started with it. We only have two dependencies defined in our project. One is Selenium Java, and one is WebDriver Manager. The Selenium Java dependency is the most important. It's where we get Selenium's Java-based API. But as mentioned before, Selenium uses a different WebDriver for each browser it tests. In fact, every version of every browser has a specific WebDriver version associated with it. That used to mean that you had to spend some time downloading all of the relevant drivers and pointing Selenium to them, and that can still be useful when setting up a dedicated testing environment for this sort of thing. But in this course, we're going to keep things simple with the WebDriver Manager dependency. This simple library downloads WebDriver instances on demand based on the browser you want to automate and the version of said browser that is already installed on your machine. Let's jump over to our Selenium example class to see it in action. We have a simple example class set up with a main method which contains our Selenium script. This script's goal is simple. Start Chrome, navigate to the Google search page, search for the term Selenium, and print out the results. The first two lines of the script are where we set up the WebDriver. The first line is where we tell the WebDriver Manager to make sure we have a Chrome driver set up. Again, this will check the version of Chrome we have running on our computer and use it to download an appropriate WebDriver instance. The second line is from Selenium, and in it, we're creating a handle for the WebDriver. Note that without the first line, this second line would fail. Once we have a WebDriver instance, we can use it to navigate the browser around the web. Driver.get tells the driver to navigate to the given URL, and in this case, we're telling it to go to Google. If we were testing our own Spring app, we would tell it to go to localhost:8080/home, for example. If we comment out the rest of the method and run just what we've seen so far, we'll see that Selenium opens a new Chrome window, navigates to Google, and then stops. That's because the WebDriver instance isn't tied to our Java program. In order to make sure it cleans up appropriately, we need to call driver.quit. Let's add that back, as well as a thread.sleep, so that we can see what our script is doing in the browser before it quits. Next, we want to be able to type some text into the search bar. In order to do that, we need a handle for the search input element. Selenium calls these web elements, and we can get one by calling the driver's findElement or findElements methods. The argument these methods expect is called a by, and it determines how the driver searches for an element on the page. Some common bys include by.classname, by.id, and by.cssSelector, which lets you search the website's elements by common HTML and CSS identifiers. Unfortunately, Google's search website doesn't have nice IDs or class names for the search bar. In the browser, we can find details like that by right-clicking on the page and choosing Inspect. It does have a name attribute, though, and there is a by.name selector. So let's see if that gets us what we want. To test if we have the right input element, we can also call .sendKeys on it with the string we want the driver to send to the element. Then, running the script, we see that the browser navigates to Google, and then the word Selenium appears. Magic! We can even get Selenium to submit the search for us. Going back to the code, let's add inputField.submit back. Now when we run the script, the browser navigates to Google, types in the search form, and submits it. And we get results back based on our search term. Pretty cool. So we can initiate simulated user actions like this in Selenium using methods like .submit, .click, and .sendKeys. You can submit forms, send keys to input fields, and click links, buttons, and more. For those familiar with the DOM, Selenium allows you to trigger events just like jQuery or a user would. In testing, this is useful because we can also check the results of a user action in an automated way. Now that we've searched Google for Selenium, we can read the results by scanning the result page for the data we're interested in, the links. Again, Google's class names and IDs aren't very useful to us. When simple identifiers fail, one of the easiest ways to select a group of elements is to use by.css selector. This allows us to use any CSS selector to select the elements we're interested in. And in this case, I happen to know that every result is inside of a div with the class name G, and that each of the results has at least one A tag inside of it. The A tag, of course, being the link to the result page. That means I can pass the entire selector div.g space A to the driver.findElements method to select a list of web elements that represent those result A tags. I can then iterate over them and use the web elements getAttribute method to get the href attribute of each link. This is the actual URL the link is pointing to. Now when I run the script, after executing, I get each of the links printed to the console. Nice job, Selenium. Now, you'll notice some questionable results in this printout. That's because this CSS selector isn't all that accurate. Normally, when you're writing tests for your own application, you'll have access to the web page's code in order to add specific IDs and class names for the sake of testing, and you can ensure that all of your by expressions are as precise as they need to be. Most major websites like Google actually partially obfuscate their page elements to discourage this kind of external automation, as it can be used in malicious ways. Although for internal testing, it is quite useful. In the next video, we'll start to integrate Selenium with JUnit, and we'll start using it to test Spring Boot applications.